cruise in yellow, what's happening if you take Mach cruise? When you increase AA divided by AI, so you are in this diverging situation, so it's happening nothing here related to the ram recovery, the total pressure is constant, and then when you are arriving here, you are starting to have the friction. Normally you will not have any shock, because it's just a small convergent you will have, it's just a small convergent, you have not accelerated the flow, you will have maybe a very small increase, a small danger if m dot is very, very high, but we will see that it's in fact not the case. I will explain you that later on. And we will have mainly m dot is increasing, the sections are constant, the speed is increasing, the speed square is increasing, so the friction losses are proportional with speed square, and so you will have a square decrease of the ram recovery with AA divided by AI. This is proportional with m dot square, because it's proportional with the speed square that you have inside the diffuser. The speed square inside the diffuser. The speed is high and then becoming lower, 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 but even if it's lower, when m dot is increasing, V is increasing also. Lower 1, but it's also increasing. And what is the influence of the Mach number? If you take, let's say, Mach number at takeoff, which is the worst case, or when you start the engine, or when you are taxiing, I don't know what will be the effect? The effect will be that you switch from the, let's say, blue situation to the orange situation, and you will increase the speed, so having the shocks, and increasing the speed, you will have also a higher speed here, and so you will have also a higher friction losses, but mainly, of course, in the region of ear, of the throat, in this region, due to the shocks and due to the higher speed that you have. Because here, so this is proportional with m dot, and you will have again the same speed. It's here that you have this problem between AI and A throat. And so what will you have when you are at takeoff? You will, of course, I'm drawing the curve from 0. There is no curve at 0, of course. So at 0, there is no flow going into the engine, so the engine is not running. But you will have, from the beginning, a lower value, and the difference will increase and increase. And you will have a larger and larger difference between the two curves when you increase the mass flow rate. Okay? And so you see that the compressor, the intake map can be explained. Of course, the map in the values you have here will change a lot. The map will change a lot depending if you are in a military aircraft or if you are in the civil transport aircraft. In fact, what I have represented here with this large decrease in both cases is most probably more a military aircraft. Whereas in a civil transport aircraft, you will have a curve that is much less decreasing, much less decreasing, much flatter as this one, and where you will have also a lower decrease if you are going to take off. So this is civil in cruise, and this is civil in takeoff. So you can represent that approximately like that. So where you have a much lower decrease and a much smaller difference between the takeoff situation and the cruise situation. Okay? And so, like this, we can understand these maps. Of course, you need to take a real one. For a civil application, and the military application. Also, we have always said that this is, let's say, not 100% theoretically correct. And how can we see that? In fact, the RAM recovery that we have explained here is not taking into account an effect like the one that I have explained here. You should also add an effect of the angle of attack. And you should also add an effect of the slip angle. So when you give a map like this one, this is with a certain value for this, and this is a certain value for that. And you should have maps showing also when you are at high angle of attack, how is it changing when you have a high slip angle, which is the same as this one, but in the horizontal plane. So what is the effect? These are secondary parameters, but these secondary parameters, especially at takeoff, for example, can become quite important. And like this, we have in fact introduced, mainly in fact understood, what is the map of an intake. The map of an intake is showing the RAM recovery in function of the mass flow rate expressed in a strange way. This is the AA divided by AI, depending on different Mach numbers. And you have a very clear difference between the cruise value and the takeoff value, and a clear difference also between, let's say, long intakes, like in military planes, and short intakes, like in the civil planes. Okay? And after this, what I will discuss, I will come back to this problem. I would like, in fact, to go a bit deeper in the understanding of what's happening in this case and in this case. Is it the only problem, the fact that when we are in a takeoff condition, that the RAM recovery is lower? This is so the next question that we will discuss after a short break.